Now we're going to move on to integration by parts. So suppose you have a function u of x and another function v of x. Now if you want to differentiate the product of the two, meaning if you want to differentiate this, then you would have to use the product rule. So remember, the product rule is you differentiate this, leave this the same. So you differentiate the u and then leave the v the same, and then plus, and then you leave this the same and then differentiate the v. So you leave the u the same and then differentiate the v. So if you want to differentiate the product of two things, you would have to use the product rule. So now we are currently at this stage. Now, if you have an equation, you can add equally, take away equally, times equally, divide equally to both sides. Well, you can also integrate equally to both sides. So if you integrate this, and then that will give you dx, integrate this with respect to x here. You are entitled to do this. So now, if you look at this here, if you look at this here, if you look at this, let me start again. Look at this here, differentiate it, and then immediately integrate it, then you're going to get back to uv. Because if you have something, differentiate it, and then immediately integrate it, then you're going to get back to the original thing. So the point here is that if you start off with something, and then differentiate it, and then immediately integrate it, then you're going to get this. Okay, so this block here becomes this thing here. Okay, but before we do that, let's try and break this up. Let's try and break this up here. So this is the same as this integral of u prime v dx with respect to x, and then plus. Hang on, plus. Now break this bit up. So so it would be this plus plus normal u and then v prime and then with respect to x. So so starting with our product rule, we can integrate equally. That will then take us to this, but then this thing tidies itself to this, and then now break up this whole thing. That will then give us this. Okay, so we are currently at this stage here. We are currently at this stage here because this here is this, and this block here is this, and this block here is this. Now imagine this as being one block, and then you've got another block here and another block here. Make this block the subject. Okay, make this block the subject. That will then give us this. That will then give us this. So basically, you take away this block, blah blah blah. You make this block here the subject. That will then give us this. Now this will serve us well because it will allow us to integrate things that we otherwise couldn't. I will give an example, and then you see what I mean. But from this stage here, it will serve us well. So in the case of you trying to evaluate it between two points A and B, then you would have to do it like this. So I will explain this another time. Okay, hopefully by looking at this you could understand it. So if you want to evaluate it between A and B, then you would just follow this. But going back to here, we are going to make use of this now. So let me give you an example. So how would you go about integrating this? So here you've got one block multiplying another block here. You see, now we can use our integration by parts. So remember this was what we had earlier. So now to integrate x cos of x, now we can make use of this now. So for example, if you let this u here be x, and then v prime equals this. So now we are letting u equals x, and we are letting v prime, that's this bit here, to be cos of x. So now if u equals x, then if you differentiate it, then u prime will be 1. Well, we are letting this thing here to be v prime. If v prime is cos of x, then integrate it. So if v prime is cos of x, then v must be the integral of this, so which will be sine of x. Okay, so to integrate this whole thing here, let this be u, let this be u, and then well if u equals this, then u prime will be 1. Now we are going to let this be cos of x, cos of x. Well, if this is cos of x, so if v prime is cos of x, then v must be sine of x. So now so for us to evaluate this integral here, we would just follow this bit here. So now looking at this block here, so u times v here. So that will be x times sine of x. So that will be x sine of x. So this block here is this block here. So now take away the integral of u prime, that's this bit here, times v. So that's simply 1 times sine of x. So that's sine of x, and then we've got to integrate it with respect to x. Oops, sine of x, and then we've got to integrate it with respect to x. You see, this thing here simplifies. We can easily integrate this. This thing here is quite difficult to integrate. So we would use this formula here to break it up as something here which we don't really care about. This is the hard bit, but we've made it simpler now. So rather than integrating this, we would try and integrate this. This is much easier to integrate. So if you integrate this bit here, it would be plus cos of x. Yeah. So currently we are here. Okay. Integrate this bit, it will give you this. It will give you this. Okay, so earlier we were here. Now all we have to do now is integrate this bit. If you integrate this bit, then you're just going to get cos of x. But by the way, when you integrate this, you should have a constant. But then you're going to get a constant over here as well. So let's merge these two constants together. So we only need one constant here. So by right you should have a constant here, but let's move that constant over and merge it with this constant here. So overall the answer would be this. You see, the good part is this bit here is really complicated, but break it up by using that formula we had earlier. So now it really boils down to us integrating this, which is much easier than integrating this times this. Okay.